So the talk is cybersecurity in a smart grid and a power delivery network. I can't think of a more topical issue today that is really it's a burning platform. And if we don't do this right, we probably pay the consequences of that. So Mr. Katzman has over 25 years of experience in various industries, including manufacturing, financial services, private equity, and energy utilities. So you see the multidisciplinary nature of Ronald's background is very important. He serves as a Director of Strategy and Operations for SME Solutions Group. He specializes in executive strategy, process excellence, smart grid, and data analytics fields. And I'll just suffice it to say that he's got a very broad background in utility space, private equity space, IT space, and especially working for utilities that you know what the regulation atmosphere you have to work under. And how does innovation thrive in such an atmosphere? So without further ado, Ron.
Hi everyone. So today, like Rudy said, I'm going to share with you a little bit about my experience in working in a utility, electric utility and gas utility, working in the smart grid field and with cybersecurity, how to not only design it, but to actually run it. You're probably going to get a little bit less theory in this class and a little bit more nuts and bolts of actually running a cybersecurity operation in a large utility environment, in a large smart grid ecosystem. So I'll share that today, and by the way, ask me anything. You can stop me anytime and ask a question if it's burning. I'd love to have some interchange versus me just kind of talking and telling you about stuff. So some of the topics today, I'll give you some of the background on smart grid, especially in the state of Pennsylvania and at Pico Energy, very specifically where I work for several years. I'll go over some of the smart grid architectures that are out there and the one that we ended up choosing and the communication networks that are associated with that. Then we can talk a little bit about some of the common security vulnerabilities in a smart grid ecosystem. That's both systems and physical access. So we'll go through some of those as well as some common mitigants to manage those security vulnerabilities. And then we'll talk a little bit about data and analytics. Like Rudy said, I can talk a little bit more about that afterwards. I have some separate slides that Bart wanted me to put together. So we'll go through that just a little bit, but then we're going to get into security policy and the actual processes and procedures of managing security in a large smart grid environment, really in a large enterprise utility. So some of the key challenges today, there's a lot of key challenges today actually. Large-scale grid systems, AMI, distribution automation, even legacy SCADA type systems. There's not one common model for all of them. It's not managing, if anybody's like a network engineer, managing a bunch of routers that are all IP based. Well, you can get tools to manage, many of those devices and endpoints. But when you have kind of archaic systems and differently developed systems, you can't just standardize security across all of them. So that presents some interesting challenges of managing security with a diversity of networks, old and new in the utility environment. Standards. I'm sure you guys know a lot about security standards. They exist, but actually implementing them, that gets a little bit harder. Getting everybody on the same page of the timing of the implementation and the trade-offs, that presents some additional challenges. And then vigilance. Things change all the time. Something I'll show you a little bit later is the fluidity of security threats, which means that a security policy needs to have some dynamic aspects of it as well to stay fresh and be the security posture in the utility, for really any environment. So I'm going to characterize some typical smart grid controls. I said some vulnerabilities. We'll go over some of the best practices of policies, how to manage that, and then also some future considerations as we look going forward. Rudy already talked about me. My partner in crime, Mark Sioni, he's a very deep security geek. He'd be happy if I called him a geek. And so he's available if you have a deeper question that I can't answer. I can certainly get it to him. He just wasn't able to make it here today. So, and I work for SME Solutions. We're in Florida. We do a lot of consulting on smart grid, data analytics, and stuff like that. And we're also a ClickView partner, which I can talk about later as well. We were partner of the year last year with ClickView now. So, a little bit also my previous life, Pico. So, people have heard of Pico Energy, right, in Philadelphia. Used to be the old Philadelphia Electric Company, then got bought by Exelon. We called it Pico after that. About 2 million customers, about 1.7, 1.8 million electric meters, and about 500+ gas meters there. Many are dual service, so you have about 2 million customers total overall in southeastern Pennsylvania. More so, what Pico is, they're a large electric utility in Pennsylvania. So these next two slides are going to look kind of old, because they are. I took them straight from the filing that Pico did in 2008 in the state of Pennsylvania. And what happened in 2008 is the state of Pennsylvania, the PUC says, we need to have smart grids. They thought it was a benefit to consumers as well as the utilities, promotes renewable energy, promotes a modern way to collect data from meters instead of people running around in trucks. So they created something called Act 129. Everybody, how many people have heard of Act 129? One or two. That's about the right level of interest. Act 129, what that did is that it forced utilities over 100,000 electric customers to put in smart grid technology and smart meters by 2025 in the state of Pennsylvania. The reason why that's unique is I figure you're in Pennsylvania, you should know what goes on behind the scenes a little bit, but that's unique. I think it's the only state in the country that has a law forcing smart grids. Everybody else has to go out and sell the benefits of it. So it was a little bit different there. But bottom line is that came through, and we put together this large presentation called Smart Future Philadelphia. We partnered with Drexel, we partnered with UPenn, Philadelphia Housing Authority, et cetera, to do some experiments and some trials as part of this program. All that led to $200 million we got from the Department of Energy to spend on this. I'm going to go to the next slide, and about $650 million state level. So it ended up being it's actually $850 to $900 million project to build a communications network, put in all the systems, change out every electric and gas meter, put in a distribution automation communications network, and all the associated systems, and of course security, and some of those customer programs I just mentioned, dynamic pricing and so forth. That's about an $800, $900 million price tag. So the point is, though, that's what catalyst of the technology and putting it in place. Where Pico's at right now, I left Pico about 6 months ago. This is relatively fresh, and I still know people there, so it's pretty close. They're pretty much done with their deployment. We built a network in 2011, 2012. We started installing the meters in 2012 through 2015. We're just about done. A couple of hard to access, a couple of commercial ones that are buggers. But, you know, we got 750,000 electric meters out there, a little over 500,000 gas meters out there. We ended up putting in about 300 distribution automation devices on the smart grid, reclosers, FCI, or fault circuit indicators, and cap controllers, things like that, to be able to communicate and control those devices as well. Things like remote connect, disconnect, that's one of the things we implemented because there's a lot of benefits with that. This has been about 6 months old, and we've done 1 million remote connect and disconnect operations at the time. I'm sure we'll lay over that right now. And then outage management. I'm sure you guys have talked about outage management in your ESC stuff. We did a lot of that using the data to integrate into our outage and restoration processes. And then we're also doing some pilots. I just talked to about this over lunch about microgrids. We have 2 microgrid pilots. Dynamic pricing, like peak time rebates and things like that. Those kinds of programs are out there. And then we actually just recently this year, Pico did some investments in smart streetlights. So the ability from the grid to control streetlights and dim them if there's, for energy efficiency purposes. So that's where things are at, kind of in your backyard. Now let's talk about smart grid. So I'm sure you've heard about smart grid communication networks. You have several different kinds, right? You have power line carrier, you can still communicate through the power lines. You have mesh networks. We ended up choosing a point-to-point network. So instead of having thousands of network nodes out there as all kind of mini repeaters, we ended up building about 170 towers that have direct communications to each what I call a smart endpoint. So what you're seeing on this here is like smart street lights controlling that. Obviously the meters, you can talk through a meter to the home area network, so in-home displays. And you can communicate with pretty much any of these things out here. water, gas, electric, if you choose water. We're doing some experiments with that as well. And it all comes back into a collector. So there's about 170 of these in the southeast Pennsylvania area that we had to build. Some are 50 feet, some are 90 feet. All have dual antennas, one for AMI communications, one for distribution automation communications. And that's probably the first step of security that I learned, at least way back when. Physical segregation of communications and network traffic in the field, and then logical segregation when you have to backhaul and it's all in one pipe. So all that, then it comes back to typical systems, right? Head-end systems that control that data that's collected there. And there's multiple systems associated with that. And then it gets back into the normal utility applications, things like your billing systems, your customer service systems, your outage management, SCADA systems, things like that. So that's a smart grid in a nutshell. We chose Census FlexNet was the technology we chose. And again, it's a point-to-point technology. You'll see, I will probably get into the differences between mesh and point-to-point networks. There's pros and cons with both. Probably the one thing I'd say that on a point-to-point network that seems pretty obvious or intuitive is that the resiliency in power outages is significantly better in point-to-point networks, i.e. instead of having to wait to rebuild the communication network in mesh paths of meters that were out of power and are just coming back onto power, you have the ability to get power out alarms and power restore alarms from those meters more directly. I would say the difference that I've seen is that mesh networks will give you around 10 to 20% of power out and power restore alarms, maybe 30% if you do some good optimization. In a point-to-point, we get between 95 and 98% of power out and power restore alarms, which is a huge driver of outage and restoration management processes and shaves time off and things like that. So that's a smart grid in a nutshell. And the communications network that we have, 2 slides on this, we call them different tiers. I'll go from the home out. The home is home area network, your in-home displays, your eventual smart homes that communicate to all your appliances and things like that, through the meter, and pretty much a tier 3 network, an AMI network, doesn't matter if it's mesh or anything, it's really communicating with those smart endpoints. That's usually a proprietary communication technology. Census, Silver Spring, Itron, Landis & Gear, they all make different technologies for communications protocols. But you're going to have some layer that talks directly to your collectors and your meters out there. We call that tier 3. And then really it depends, backhaul is really how do you get all that information collected in the field back to all those systems I showed in the previous slide. We have 2 ways of bringing it back, and normally you have 2 ways. If you're lucky enough to have a tier 3 tower sitting on a fiber location, like at a substation, you backhaul it straight through fiber. If you're not lucky enough to have a tower that's on fiber directly, you use a WiMAX to get it from that location back to a fiber location, and then you backhaul it through the fiber. So those are the different tiers of a communication network, and I'm going to go into some of the vulnerabilities associated with managing the security at those different tiers. Another way to look at it is you have your meters communicating to your local network here, and then that backhauls it through a fiber, usually a fiber sonic ring. If you already have it installed, if not, you have to hop it here through a WiMAX link back to a fiber drop, and then it gets backhauled. So that's the basics, right? Smart grid, I assume you guys know something about those, but if not, there's a high-level overview grid. So that's the basics of a smart grid architecture. Now, vulnerabilities and security, applying security onto that network and managing it. So you see here, got some different levers, right? Where are your bigger vulnerabilities? Well, the head-end system usually pops up as the number 1. That head-end system that I showed earlier, you can control pretty much anything on the grid. If somebody went rogue, they could try to disconnect 100,000 people's power, right, from a remote disconnect switch. So you have, not only you have web-facing, right, so you have security threats there. You also have human users, so you have security threats there. And the amount of control that you have to have in a head-end system is heavy, so there's a lot of impact if somebody is able to take advantage of that vulnerability. So you have those different levels, and then it continues down, backhaul, reasonably secure, your network tower is reasonably secure, and then you get to your meters, They're generally not the biggest problem in the world, but not always. Right? Everybody knows security, not always that way. And so that's kind of how the cascade of vulnerabilities exists in that architecture and that network. Stride and Dread. Anybody Stride and Dread frameworks, enterprise risk management? You can use different approaches to get rather defined approaches for security and managing security in these different environments. So using those kinds of frameworks is a good thing. It's an accelerator and helps quite a bit. And then also consider the broad range of risks. Right? You not only have power delivery at stake now, you have money at stake now, you have reputations at stake now. So those are things that go into this security policy as well. And then lastly, one of the things that we put this on here, because we actually heard it from people that, well, this is pretty modern stuff, so what's the worst that could happen? Don't say that ever in a private setting of job environment. Like, what's the worst that could happen? Don't say that. Don't do it, and it probably could, probably won't happen. We actually heard those people say those things about these things because they thought that they were much more mature than they are, and we're just not that level of maturity with smart grid and security right now. So that's some security background. Now some vulnerabilities. And this isn't crazy rocket science, but it's a way to think about it. Security policy is managing your vulnerabilities and being aware of them, and then having a policy and a process to focus your resources on the most important, most critical vulnerabilities. So I'm going to show you that, but here's some basic foundations. So we'll start with the meter. The yellow is the vulnerability, the green is a common mitigant of what you do to try to resolve that vulnerability. So meters. You obviously have the head-end communications. There's a radio on every meter to communicate back, and that's a risk point. Encryption, and PKI is a good anecdote for that, but I'll show you a dashboard later that not every meter can get encrypted. So you have to manage those vulnerabilities. So a meter communicating without encryption is a heavy vulnerability to manage. Someone can intercept that traffic and figure it out. But I would actually argue that a much deeper vulnerability is this optical interface. Every meter has the ability to USB into. You can USB into the meter. You can not only collect a lot of data off that customer in the meter, but you can actually collect the keys, right, the encryption keys that are being used. And with enough time and persistence, somebody can make sense out of that and take over the network and hack it. This has happened in places. I read about one place was in Puerto Rico, actually, that had some ex-utility people that worked for the communications company. Started doing some things they started using that knowledge and experience they had in not the best ways. And they were able to fiddle with people's usage and bills. They were able to send out some rogue signals and things like that. So the meter itself actually introduces a fair amount of vulnerabilities that have to be managed. Another layer is, this is an IED, an intelligent electrical device. This is a recloser. An interrupter. It's like an interrupter. So you also have the head-end system communications there. You have a radio on that. And if somebody's able to take control of that, they can do switching whenever they feel like, right? And that's not a good thing. So that's and that'll probably get you, if somebody hacks a meter, might not be front page news. If somebody hacks a recloser, it probably is going to get closer to the front page. So more limited vulnerabilities. I don't believe there's a huge vulnerability of direct access. Could somebody do it? Yes. I don't see a lot of rogue agents climbing utility poles and taking a risk of electrocuting themselves. But I think that the communications vulnerability is a big one here on these devices. There could be thousands of people's power on just this one device, and somebody controlling that's not good. So that's another layer. The actual towers themselves, this is one, I knew something about cybersecurity. I never really dealt with physical security before until I built this network. And so having gates and fences and access controls and key cards and all that stuff, that starts to apply when you get into that network level. So you have to have policies, processes, et cetera, to manage access controls of the physical location. If you're able to get these in a substation, it's great because you can ride the coattails of all their heavy access controls. But if not, you have to build it yourself. And then, of course, you still have the communications vulnerability and risk out there. And then lastly, as I mentioned at the head end, you had all kinds of challenges here in the head-end system. We had hundreds of users of our head-end system. So you have user access controls, levels, security levels that have to be managed. You have to audit those things every 90 days or so. So you have all that stuff associated with an application. And then you have rogue users, so putting in things like governors to not let somebody turn off 100,000 people if they so choose. Things like that, you have to build those things. They don't necessarily come out of the box. Plus, many times this is accessible through the web, so it introduces those kinds of holes and threat vectors that exist from a normal web application. So those are the different layers, right? And some general vulnerabilities and some general mitigants on how to manage security in a smart grid environment. Now, data, I mentioned data before. So all that stuff, all that, those endpoints out there and all that communications network, I bring back a lot of data. How you manage that data, not only to run your operation, but to manage your security is very important. It's critical to the success. So what you're seeing here is a snapshot of a dashboard that we built. And what it shows how many meters are encrypted out there. So at this time, point in time, 1,696,000 meters were installed, and 99.11% of them were encrypted. I take that back, 98.7% were encrypted. But you see all these little hops here? I don't know if you can read that, but it's a whole bunch of nitty-gritty stuff. Did the meter get its setup ping? Did the meter get a binding ping? Does it have its lat-long coordinates? Does it recognize its firmware? All these things need to be in order to be able to encrypt a meter onto the network. So what happens is, and the reason why I'm showing this, not only just to show data, but the role of security. Now has to worry about this meter didn't get its metrology firmware. Sticking on that one, we had 1,491 meters that did not recognize the metrology firmware. Normally, security would say, well, go have at it, ops guys, go fix it. Well, now they have to worry a lot more because until we fix it, there's a security risk out there. So we've actually gotten some help from security and some oomph on prioritization, maybe more resources, et cetera, to address these kind of shortcomings that are on the critical path to encrypting an endpoint. But the key is that managing it and knowing it and being able to not only say what percentage are encrypted, but what is the obstacle? What's the barrier to all those, what are they, 12,000, 14,000 meters that aren't encrypted? Why? And what kind of action can I take? And that's helpful from a security policy that you actually make it actionable data, you can quickly address these things and manage your security.
Oh, I have a question. So what kind of encryption standard do you use? What kind of encryption protocols do you use in those meters?
In the meters they came with the encryption capability from Census,
Right.
which is, so we're going to test it here, 128-bit 128-bit encryption. It's PKI, so we actually swap the key with the head end of the meter itself.
Right, and then you symmetric encryption, right?
Yes, we do not have asymmetric encryption just yet.
Okay, but for PKI, first you exchange the key, and then you use that key for all data transmission. So you just use, or you just use PKI.
We just use PKI.
Yeah, I mean, after PKI, so during PKI, you exchange an encryption key,
Yes.
and then you use that that key to encrypt, to do a symmetric encryption of all the ordinary.
Yes, I'm sorry, you said symmetric.
Right.
Yes, I'm sorry, I thought you said asymmetric.
Oh, okay.
That's right. So we do not have asymmetric yet, but that's exactly how it operates. So anyway, this is managing the operation. I was an operations manager. You have to know what your actions are for the day and what your security risk profile is. So using the data. What's more important, I mean, this is kind of almost after the fact. What's more important is, what I'm going to show you is the criticality of having a good, well thought out security vision and policy and strategy, and then the processes and procedures to support that and actually run it to manage these threats and focus your resources on the most important threats. So here is a snippet of Exelon's security policy. I'm not going to read it all. You guys can read it. But what I will comment on it is a couple things. Number one, Pico had the luxury of having a larger corporate parent called Exelon that had a security team. And so they help with running governance, giving standards, giving that push to say we should be doing these things. So that's one thing that exists, which is a very big aid if you're in a larger company to have that kind of oomph or push. The rest of these guiding principles is they try to take a well-rounded or robust view of a sensible security policy. So certainly it starts with managing your risks, right, and compliance. One thing I like from our security folks is that compliance is not equal to security. So you have to think a little bit beyond just, am I in compliance here? It doesn't necessarily guarantee that you've addressed all your vulnerabilities. So recognizing that I thought was important. So of course you deal with your vulnerabilities, a resilient infrastructure, a balanced approach here, right? You don't want to have too many policies that you're kind of stuck in the mud. You don't want to have too few that you leave some open vulnerabilities. So coming up with a sensible, balanced policy I think is important. If you go to these later ones, enterprise-wide commitment. I'll pick on the people aspect again, and you'll see it again a little bit later. Like safety, it's everyone's responsibility. So you got to consider the people side of it. That means security departments sponsor things like training. If anybody used, something I was just using the other day, anybody ever used something called FishMe or FishLine? These things? A buddy of mine works there, and what they do is they set up phishing scams, right? But really good ones. Like they somehow get the email address of the admin of the CEO, and then it looks like an email from the CEO to the admin saying, hey, we're past due on this vendor, please wire money over here to this account. And if the admin selects that link, it takes her to a training page, or to a training page. And so it gets that awareness of, hey, don't do that. You just took a big risk. And running those kinds of policies and procedures, security does that because they know that getting the people trained and in the right mindset of security is one of the biggest assets they can have. So they incorporated that in the policy. And lastly, economics. What's the point of spending $10 million in security to save $1 million? Maybe some reputational things, right? But you don't want to have an excessive security policy where you spend 98% of your revenues on security and you have a really secure product, but you're wasting all your money on security. It's not necessarily the right payment. So you come up with a security policy. This probably took, I want to say about a year, maybe a year and a half to actually get approved and reviewed and fine-touched and so forth and rolled out. And then to actually put in the support legs of actually training people, actually figuring out what your security and risk policy should be and what are your vulnerabilities. That's what comes underneath it. That's the real hard part. So to execute this kind of policy, you need some tools. I'll show you a couple of tools that we use. One is a typical, I call them payoff matrices, but this one's a little different. Typical impact and probability, risk management, kind of 101. But they actually do a pretty rigorous job of this. They look at things like the black swan events, and they look at things that are really heavy and that are happening right now. They look at smaller things too. And so it's a way to say, obviously I think you see the grid, the curve here, right? If it's within our tolerance, we recognize it, we log it, but we don't necessarily do anything about it. Right? But if it's on the other side of that curve, putting in action plans to say how are we going to mitigate it, how are we going to prevent it. And I'll show you the process here in another slide or two. But it's one of those things we actually have to be worried about if it scales on the other side of that curve. So this is the first what I call kind of filtering or narrowing exercise, that you can't worry about everything. So it focuses over here, focuses your energies on the things you should be worried about. It's the first pass at a filter for to be able to do that. Another tool is stratifying your systems or categorizing your systems. And this is a common thing that people do in disaster recovery modes as well. But if you segregate your systems, most important here being real-time systems, SCADA systems and other networks that are real-time, those become the cream of the crop. And now you have to invest in those and focus on those and worry about threats for those areas a little bit more so than maybe a bronze system. Now, bronze system owners always get annoyed at this slide because they're like, what about me and what about my security? Actually, this is a very good slide to show them that we do care about your security of bronze systems. It's on the map. So it's not just over there, we don't care about it. We actually know you have a RON system. We know there's some normal business expectations on it. But the threats aren't nearly as impactful on those level systems. Point is that you have a model here and a framework to say, I'm going to focus my resources and energy on some of those networks because of their criticality, and I'm not going to spend as much time and energy on others because they're supporting less critical business processes. So just more narrowing tools, right? You can't solve everything all the time. So those are tools that you use to kind of implement your policy and know that you have limited resources to actually manage all the security of all of your assets. Another tool is a process. Prevent, detect, respond, and recover. And it's pretty simple and straightforward. I think I have some little things in here. Prevent the majority of intrusions, stop known things, detect the actor in action, respond to it, and then recover from it. So let me give you an example. And this is, by the way, this is kind of it. This is the heart of running security. Having a policy, having tools to manage your work and focus your resources and your time, and then having a process to go through that if you do have to worry about something, you've already thought it out, it's repeatable, and you can just run it. That's kind of running security operations in a nutshell. So then let me walk you through one. I think I put one example here of a process that we actually used, that we've had to use, unfortunately, for multiple occasions when we've gotten some vulnerabilities acted upon. And the example is that somebody had some malware. The real example is, I didn't make this up, this is a real example. A vendor was in doing some work, put in a USB drive, it had some malware on it. And it actually had malware that didn't have a known pattern. So, let me walk you through the process. Monitor, identify, prevent. Monitor, identify, prevent. There's people on the treadmill all day that are monitoring, identifying, and preventing. But when something happens, and by the way, some of the tools here, we receive information from the government describing malware. We have signatures that created to add it to the detection profiles. Right? That's how you do this stuff, and then you prevent it. Anti-malware products are updated and automatically detect these things. So you actually are able to prevent that kind of nuisance stuff about upgrading your security patches and your OS and how many times your iPhone comes out with updates. What was that one comedian said that if, what is it, Adobe always needs an update. It's like, who needs an update in 2016 every week just to have your application work, right? But managing those nuisance updates actually works in this area because you're constantly getting new information, new threat vectors, and new signatures, and then you constantly update your malware detectors to prevent anything intruding from them. But in this case, all that was great, got penetrated, and a vendor comes in here, and it triggers an anomaly at a facility. Software doesn't know the identity of the malware. Oops. So somebody responds, and they evaluate the attack. And we got a group of people here, an ICS cert notified, the vector for the malware is entry. It's a USB device inserted during a routine update by a vendor. Oops. Contain it, eliminate the threat, talk with law enforcement, talk with those security experts. Now recover from it, including a post-mortem. You have a short-term recovery, hey, stop that, and prevent it. You have a longer-term one too. Do a post-mortem. What's the root cause? What can you do to prevent it in the future? This one was upgrading the Windows 7 project. USB protections are planned to be implemented. Great. And then you take that and you feed it back in to do the #1 goal, which is achieve resilience. And you feed it all the way back into your monitoring and your upfront preventative processes. So as I said, that's really it. Running a security operation for a smart grid environment it contains the strategy, the data, the procedures and the policy, the people, right, to know what to do with these things and to be available. If this happened at 2 in the morning and a security person's sleeping, they don't have a pager, or they don't respond to it, you've lost probably, right? So all the people, processes, technology has to be in place to be able to pull this off. So, looking ahead. Some Rudy and I were talking about over lunch. I don't think it's going to get simpler. I don't think it's going to get easier. I see hybrid networks continue to go out I see the desire to put more and more communications on the networks. Water and gas and electric. You can do a lot of different things with those different energy sources. So I don't see that going away. You have a lot of entry points for vulnerabilities. So that's not going anywhere. Microgrids and distributed. We'll talk about that over lunch too. I'm a big microgrid fan. I like distributed energy quite a bit. Introducing that type of information back into the grid hasn't been done tons. I mean, there's some things that have been done. Has it been done on an enterprise-wide scale and has it been done to maximum security? Haven't seen it yet. So it's still kind of going to be something that develops and continues to grow, but it heightens all those things we just talked about having a good security profile and be prepared. And then the Internet of Things. The Internet of Things is going to wreak havoc across this earth, and someone's going to eventually send somebody the wrong data or not have the right footprint and stamp, and something bad's going to happen. But the Internet of Things is going to put even more stress with the communications and the sharing of information across all those different assets. So, 5 final thoughts on smart grid and security. The first one, I put a little what I thought was bold here. Threats and vulnerabilities evolve continuously, therefore security must evolve similarly. Right? And that is hard. It sounds kind of simple. It's actually hard. It's hard to get IT folks that are security based and have very good technical skills to say, okay, now be flexible, be fluid, roll with the punches. I struggle with that myself, right? I'm an engineer, right? Very linear. So I struggle with that myself, but that's a key thing. You've got to be fluid because the threat vectors are fluid. Number 2, Internet of Things grows the surface, right? The threat surface. Just more opportunities, more communications, more connectivity. So it's something to be prepared for and aware of as that continues to grow. This third one is maybe a little too late, but as you all know, a good design principle is to build things in from the start. I wouldn't say that security was really well integrated from the start out of the gate with smart grid technology. I would say that it existed, it was considered, but I'm seeing a fair amount of work that's needed to actually plug in some holes that you wish you'd have thought about it 5-6 years ago when you designed the system originally. So I see a lot of rework and a lot of system patches and duct tape, if you will, used to limp along because we didn't do a good design in the first place. Cascade of vulnerabilities and gaps. This one, I put in a little bit of extra words there, but it's usually not one vulnerability that kills you. Any security nerds here that talk about kill chain? The kill chain is when you have vulnerabilities in many different areas, and they expose the couple of gaps that you have in those areas or your vulnerability management system. So likely somebody says, I got the killer vulnerability, it's not going to kill you. But many vulnerabilities that expose the many different gaps that you're going to have in your security policy, that's what can lead to, not quite a death spiral they're reading, but something, right? What's called a kill chain. And then lastly, I said to get back to the people. I can't stress it enough. Having good people that are aware, in tune, well-versed in the impacts, clear on what their responsibility is. Sometimes it's as simple as just don't hit that external link. That's it. But having good people is critical. And like it says there, the people element provides both the strongest and the weakest link. They're going to think differently than a computer to notice something that should be awry or that shouldn't be there, right? Hey, this looks wrong. I'm a human, I'm picking that up. That's a huge asset. It's better than a computer. Not as fast, but better than a computer. But they can also make mistakes too, right? So it can be your biggest vulnerability to have to manage as well. So that's really the takeaways there. 5 final thoughts on managing smart grid, security in the smart grid world. That's all I have.